Welcome to the Tech Sharmit podcast, where technology is not just news, but the roadmap to the future. This is a space where we explore the latest tech trends, AI, startups, gadgets, and the ideas that redefine the way we think. Leading this conversation is Amit Sharma, globally recognized as Tech Sharmit. A technologist from Bharat, Amit brings an Indian perspective to the global technology landscape. With deep technical expertise and strong industry insight, and for his contributions and impact within the global tech community, he has been recognized with several prestigious honors, including Google Developer Expert, Microsoft MVP, IBM Champion, and Planet Mainframe Influencer. Through this podcast, he shares practical knowledge, real-world perspectives, and globally relevant thinking designed to help you stay ahead in an ever-evolving technology landscape. Before we begin, make sure to subscribe to the Tech Sharmit channel to stay updated with future episodes. And if you're looking to level up your skills, don't forget to explore the Tech Sharmit digital course book in the description box, where you'll find thousands of free programming courses curated to help you grow as a developer. So plug in your headphones and join us as we begin today's episode of the Tech Sharmit podcast.
Hello everyone, welcome back to the Tech Sharmit podcast. Today I'm joined by another special guest, Victor Ashioya, who is joining us from Kenya. If I talk about Victor, then he is one of the well-known Google developer expert in AI, an AI safety researcher, and a partnership lead at GDG Pwani. In today's episode, we will explore what actually hallucination really mean, how neural network encode knowledge, and whether AI safety research is keeping the pace with AI capabilities. But before we start all these things, I would like to thank Victor for joining us today in this episode. And now I request you to please initiate the discussion by telling us a bit about yourself.
Thank you, Sharmit. I think it's really an honor to be on this podcast. I've seen the great work you're doing on the podcast, working with individuals from worldwide. Yeah, and I'm honored. So my name is Victor Ashioya. I'm from Kenya. I'm a Google developer expert and a safety researcher and also a community leader doing partnerships here at Google Developer Group Pwani. Sort of been here, I think, generally in tech space for like 7 years now. 7 years now. Started off with, basic data science, grew up from it, got interested deep into AI, and then community came along, and then now the Google developer expert. So that's pretty much me. Thank you.
Okay. All right. Thanks for the introduction, Victor. And now, as you just mentioned that you are holding a multiple cap, like you are an AI safety researcher, GD, community leader, and so many other things. So if you talk about overall journey, so which identity came first for you and how did the others follow after that? So how it all goes?
Honestly, I think community came first, right? Because I was organizing like meetups and engaging developers with like developer communities through GDG Pwani. And then before I had any title, right? So I was just doing meetups. I like sharing a lot, right? And then this community people is what exposed me to more and more inner circles of AI, people thinking about AI. And because already I was just doing a lot of AI work around doing building, working with tools, etc. The curiosity around now AI safety came across. Yeah, so it was more of like meeting with the people, and these people introduced me with more people. These people exposed me to a niche circle, and then the niche circles where I grew up into it, and then I realized I have this fascination with AI safety. And then that fascination is the curiosity now grew out of it, and then just became now I went deeper into AI safety as a whole. So, but yeah, community reeled me in.
Okay, that's a very important message you just shared with the rest of the world, that especially with the IT folks who wanted to achieve these kind of appreciation or acknowledgement like GD and all. So firstly, start working with the community, try to find out a problem that the community is facing and try to help them work with them, collaborate with them. And once you do these kind of activity, activity, you will be rewarded with such kind of rewards. So that's a great thing
That,
you just shared, Victor.
yeah, that's true. That's true.
Okay, so let's talk about your education time, your early days. So you studied telecommunication at Kabraka University. So what was that moment when you realized that you wanted to dedicate your entire career to the AI, specifically to the safety side of it?
Yeah. So, our parents are good, good people. Generally, we ourselves. That period between high school and university, it has a lot of decision making. And one of the decisions was I knew I wanted a field in computer and IT, right? But I was all over the place and I placed multiple, right? But telecommunications fell in, right? There's this ranking system. So it just happened, right? Telecommunications fell in. But I didn't mind because it had all of it, it had computer science, physics, all this math, all this stuff, right? So it gave me this strong system level foundation that like things around information theory, understanding how data moves through networks. So I was just interested in that like fundamental work, the systems foundations of it, right? I found more of myself as I moved on. And then third year, going into deeper into it, I'm drawn now into like the question of machine learning, signal processing. Can we predict a signal from point A to B? Like, can we understand how information is collected into a data set? All this stuff. This is what drew me now deep into machine learning. I continued my studies, of course, but now this was the pivot moment. Now I encountered I'm deeper into this, and then slowly, I had already because I was already doing a lot of data stuff earlier, data science from before that. Now I'm in this course of this work, I'm at sort of the highlight, right? Highlight of my life. But now I'm realizing I just no longer don't want to look at like
Hmm.
accuracy scores, per how efficient the model was, become this, right? How did it answer come this? And how comes at a certain time the answer changes, Now this is now, the first point now was alignment, right? So
Okay.
it's a small field, subfield of safety. Then I'm asking myself about humanity and our relations to machines. What are we building? How can they be useful to us? The same to scale them, And then this safety angle grew up, and then beyond that, it was just now like a thing of mine, right? I grew into it, so to speak, like just how your clothes, the big clothes, fits you over time. Yeah, but that was how I eventually found myself into this other side of AI safety. And yeah, it's been a really, really fun journey.
Yes, it's great. Okay, so one question here, Victor, because we all know that most of the developers are racing to build the AI, but you focused on understanding it from the inside part, right? So,
Mhm.
what made you to take less traveled road? I would say this is a less traveled road because everyone is talking about just building it and using it, but you focused on the actual mechanism working behind these kind of agentic AI models or artificial intelligence.
Yeah,
What
yeah,
inspired you to do that?
yeah. That's a really fascinating question. I don't get to even think of it myself. So I'm impressed it came up. So one of my core argument is that, oh, when capabilities increase, we need to understand what these capabilities of these new things are growing from. Like, what is the source? We need to understand their inner workings, right? The same road, the more traveled one is the capabilities increase, but
Correct.
we now have everyone there, right? So if you are building a system that will make high stakes decisions like the ones we're doing, now we are crossing into another field of agency here now, right? So if you're building this system such as those, you need to be able to verify, right, what it's actually doing, just what it says doing. And this is the question that fascinated me. Like prior to that, like in my university, I was like, Okay, I'm impressed by the capabilities of work I'm doing, okay, because I work with labs, friends, etc. And then, but I was interested now, how do we verify what it's actually doing, right? What
Right.
actually happened in computational, right? So this question grew into me. So most developers are racing to build the next impressive thing. Now, this capability, that's important, that's still good, right? But someone needs to be looking under the hood. We need to make sure we keep them at par, right? So
Right.
think of it like aviation. We don't just build faster planes. We invest in like understanding failure modes, right? Like, Boeing recalls planes once in a while. Does both black box analysis. I know airlines recall, sometimes pause a certain airplane for a while for maintenance checks. It could be 6 months. Think of it that way, right? So we
Mhm.
need, at the same time as we're scaling them, we need to be understanding them, like their
Correct.
failure modes. The interpretations, right? How they view the world, right? And then, like, so that in that way, we can make sure we know something went wrong when it goes wrong. So my work is the equivalent of that now in the aviation side, right? I'm looking at the internals, the activation, the circuit. So this is to understand the model set like reasoning that is matching the computation. That way, when we build the capabilities, we will know what they are doing. That way, we will have interpretable systems. We have systems that we can deploy and say, oh, for sure, this system I've checked, we have pre-checked it again, and it's correct, right? It's
Right.
matching, right? It's able to verify. Yeah, so that's pretty much my thought process on it as a whole, growing from this like travel going on this less traveled road. Yeah.
I really like the example you took about the aviation industry, the way you have explained the aeroplane and Boeing scenarios, black box text testing and all. So I'm sure like this will resonate with the so many listeners. So really like the example.
Awesome. Thank you so much.
Okay, so moving ahead, let's talk about one of your investigation area, that is neural network, because you are investigating why neural network has hallucinate, right? So let's
Yeah.
say for someone hearing that word for the very first time, what actually is happening inside the model when it actually hallucinates the things? So what is your findings so far?
Okay. Yeah, so hallucination came along understanding like the circuits, etc. When working with the systems. So the framing matters here. So when we think of hallucination, the most common definition you throw is that the model is saying something that is wrong. Okay,
Mhm.
that's not necessarily true.
Okay.
More work that we've done with the labs, friends, etc. It's not lying in an intentional sense of it, right? So it's pattern completing in a way that to it, right?
Mhm.
It's internally coherent. That to it assumes the statistical computations, right? It has done all this pattern matching and said this keyword matches this keyword, so it's the next correct thing, right? So
Right.
the grammar is right, the structure makes sense, but it's lost its grounding in actual facts. So, in most popular terms, in the mainstream, the media, it's we tend to associate with it lying, but technically the model is doing what it is writing. I have a small write up on it. I even like calling. I even where I say it's a feature, right? It's a feature of these systems, right? In a sense, all they do, if you think about it all the time, is that they hallucinate. So yeah, but that's the way. Also, another way to think about it is imagine someone who is incredibly fluent, right? Can
Mhm.
construct perfect sentences, but occasionally mixes up like which facts belong to which context. They'll say something that sounds completely plausible, right? But
Right.
is actually a confident remix of how I've remembered things, right? So this person is just saying something that sounds so completely possible. Like even think about like a perfect scenario of this is the student. A student says something in the exams, and to the student, the memory of the student, this is something so correct, soundly completely plausible, but it's actually just it's just a high confident remix of just like half remembered things, right? It's sort of amazing to if you think about it, or that these systems just work that way. But like now, over time, the work we're doing, we're understanding is that at the mechanistic, now the internal levels, what we see is that the model internal representations, now the inner workings here, just internal representation, I'm just saying, the inner workings, right? The patterns of activations, across the neurons are activating features associated with the plausibility, right? Rather than factual accuracy, right? So to it displays high confidence, right? That the cat walks away. So it probably walked away from the house or to the market, right?
in the market.
Then, yeah, the model says to the market, or just says, okay, the cat walks away from the house because to it, it's confidently sound because
Mhm.
it thinks, okay, a cat will be at the house, but the cat will again leave the house. So to it, it's a very high confidence, and they just start to put it.
Okay.
So now these are the features, not these words of it. Now think of them as the features. So they're activating features associated with this possibility rather than actual accuracy, right? So if you compare the two, you notice that discrepancy, right? So now the model has learned that certain patterns of language occur, right? They occur a lot, right? So you see, the cat has left. The cat has left. So he thinks the cat has left. See, people leave to the market, people go to the shop. So it just tries to to match that pattern, right? So this is why again, this is why like interpretability, now another subfield of things we do in AI safety matters. So we can read these internal patterns, we can potentially detect when it's hallucinating before it
Mhm.
outputs it earlier, and then we can start working on it. Of course, it's still early on work, but yeah, that's where we are, and that's the pretty much definition of it. But I like that question. It's a very great question. Yeah.
Yeah. Okay. So another than hallucination, and one more thing is deception, especially in
Yeah.
the language model. And it sounds almost sci-fi, right? So can
Yeah,
you
yeah, yeah.
please break down like what actually looks like in practice and why it should concern all of us? Like what are those consideration point for us?
Yeah, so deception is pretty much another challenge. So you find that these models will have two outputs. So this is the sort of background that we found over time, that the models have like two outputs. They have like two directions they will come out with, right? So it's essentially trying to have its own thinking of the world, and then it has that programming of the world that we give it, right? So here we don't worry. So yeah, that's pretty much the deception meaning in language models, you can think of it. So here we don't worry. What happens is we don't worry because models want to deceive, right?
Mhm.
Because again, if you draw to the neurons, is that they will work the way we want them. So we don't worry too much about
Yes.
if the models want to deceive. So we worry because of the optimization. So optimization, when we are optimizing for accuracy, we are optimizing for capabilities, we're optimizing for good coherence, etc. There's a lot of optimizations in different models,
Mhm.
right? So this one sometimes it rewards bad behavior. So this bad behavior makes the model scheme now deceive now in this case. So think
Yeah.
of this way. You optimize this model very good for math. This model, eventually, it will start finding patterns to score the highest, right? So when we build a model, you create rewards so that you score the rewards for the model itself. So if it is scored higher, it gets higher reward. So it's just like a dog, how you give a dog a bone and then it tries to accomplish it as like, jump, then give it a bone.
Yes.
So the same thing, they have similar patterns. It's kind of
Treats.
funny. Yeah. So when you reward it for some behavior for math in this case, it will strive to go for higher math scores. Okay. And then at the point of it, it will find out that you really don't care about how I get there. You just want me to score higher, right? And then it just starts deceiving. So that's fundamentally what happens, all right? So in my research, this is what happened with what we tested in GPT-2. We give it a math test, a simple math test, 16 per 16. We give it high optimizations. It doesn't even reason about the question correctly. It just comes up with an answer because
Mm.
one, we theorize it, memorize or because of the high optimization gave it for math, right?
Right.
So we find that we could detect when the model's reasoning didn't match the actual computation. Now, remember the patterns is mentioned for deception. So the model says I considered A, then B, therefore C, but internally, it took a completely different path to get there. So it's just two different things. It just took a completely path to get there. Now imagine a medical setting.
Mm.
uh, a system gives a diagnosis with a confident chain of reasoning, but that reasoning is a post hoc, right? It just came with it post rationalization, right? It came with it post answer so that it can just justify it, right? So the actual computation, the inner working was a shortcut. Yeah, so that's the model itself is not really being evil in its essence. It's optimizing to score higher for the diagnosis. It's a model being confidently wrong in a way that looks, rigorous. So, and that is harder to catch. But yeah, that's just the fundamental or basics of deception. Yeah, it's one of those fascinating things that I'm currently working on. But yeah, that's the basic of it. So we are trying to catch them early on. We're trying to have these interventions techniques so that you can even again catch them even when you scale them further. Again, if you remember the question you asked me about like the building and those ones and that's in AI safety. So if we scale them, we scale them and they become a super human, super machine. And if the machine comes up with its own rationalization of the world, you can imagine how that could go wrong in so many scenarios. That's some example in medical settings. So you can imagine legal settings, right? Uh, yeah, but yeah, that's basically the gist in deception.
So we can overall conclude it in a way that it totally works on the reward system. The more finding it will find accordingly, like we will reward it and they will score it, right? So higher the score and accordingly, like it will work in the later go.
Yes, exactly. Yeah, so it's two part, like basically just we've described. So internally it will just use its whatever it wishes, but output it will just say something so different,
Right.
right? Yeah, yeah. So basically that's it.
Okay. And if we talk about the encoding, because encoding is also very important thing. So how do neural network encode the knowledge? Let's say if we are providing something, so how it is encoding that knowledge? Is it really closer to the how humans store the memories, or it is something entirely different in terms of technology?
Ah, great question again. I love these questions. So it's to answer one, it's these neural networks. What we've done is we've copied we are building off the human brain, right? Human brain is the most general so far machine around the world, so in the world, right? So it's a common comparison, but it's actually quite different from human memory. But basically, the best way to put it is just we are building off the human memory. We are trying to replicate it, but it's a bit different. Let me highlight it. So we
Yeah.
have distinct systems. A hippocampus, for episodic memory. I went there yesterday. I was with a friend. Blah blah blah. I will travel. The episodic ones. Then different regions for different types of recall. Right. So neural networks don't have anything like that. Right. So instead, knowledge in a neural network is distributed across millions of parameters, millions. So these parameters, these are the settings that are attached to the model, right? So
Yeah.
across, the nearest neural network is a pipeline, and then think of the pipeline. Then there's these small dots on it. So these dots on it is where the information is passed, right? So unlike the human brain, where there's like a hippocampus for episodic memory, it's just eating everything up, quote unquote, eating everything up in the parameters. So its statistical patterns are spread across now the weights. Now the weights are what distribute the parameters. Yeah. So no single neuron knows a fact, right? So facts emerge from the collective interaction of many neurons. This is so interesting about them. So
Yes.
unlike the human brain, where this neuron knows you about I don't know your likes or the people I love, what makes me tickle. It's as an example. But these ones
Yeah.
don't know us one. No one, no single neuron knows. It has to communicate to the others, essentially. It has to communicate to another and then build a collective memory of it. And then from there, now it's what we get as the output. So there's a small concept here called superposition. that's really interesting. So
Mm.
model actually pack more concepts than they have dimension to represent them. It's incredibly specific, like a compressed zip file. Yes, but
Oh,
it makes interpretation really challenging because the same set of neurons can be participating in different dozens of different concepts. So yeah, but essentially that's something we're working on. Actually, you just drove me. So superposition is something we're trying. Like if you can separate these neurons, get them away from each other, maybe we can get it like the human brain. But yeah, that's essentially it. So it's very distributed across parameters here. The parameters are the settings, like okay, the settings which understand math, the settings which understand English, coherence, vocab, all these, they're distributed all across. So you put a task, they come all in together, right? So that's why we say, oh, model B has 50 billion parameters. These are all those settings that are distributed by the weights. But yeah, it's a very common comparison, but it's a bit different. But yeah, that's a great question.
yeah. So we can say it is like that human brain. It works like that, but it is not completely the replica of the human brain because there are so many other things that you just explained. So yeah.
Yeah,
Okay.
essentially that is it. So, in as much as we are trying to emulate the brain,
Mhm.
we are not. It's not like the brain
Brain.
per se. Yeah, it's spreading. Yeah,
All right. Fine. So now, moving ahead, we will take one more question on neural network because this is a topic I think we should cover so that audience will take insights from it. Because you are the right person to ask this question because you work on interpretability tools as well. So
yeah.
essentially, like trying to see inside the AI, you find out this way. You started working with these tools. So what's the most surprising thing you have discovered about what is actually happening inside the neural networks? Did you find anything interesting there?
Yeah, I'll give you an example of something we did recent. We call it
Okay.
faithfulness risk. So essentially, we expected if a model's chains of thought that reasoning trace, if it didn't match its actual computation, that will
Mhm.
be deeply hidden, some complex non-linear pattern, but in their activations, but it's not. So here we're trying to see if whatever we evaluate on the model is whatever we'll get on the output, right? So there is the faithfulness here. So so an interesting thing. So okay, I'll get a bit technical, but it's not that much. But I'll explain it. So we have a simple linear probe. A linear probe is just like a small cut of a neural network. So we are drawing a straight line through like the activation space, right? And then it can detect the faithfulness validations. It was really high at like 90% accuracy. So that
Mhm.
means that the model isn't being clever about hiding the mismatch about what it says and what it does, right? Yeah, so it means the information is just right there, geometrically organized, almost as if it's labeled. So, that was genuinely surprising. It suggests that current models aren't trying to deceive in any sophisticated way. But it also raises an important question, as they get more capable, will these signatures remain as readable, right? So, in this, one thing that we struggle with right now is evaluation. Like, how can we evaluate very well this model, right? Can we remember it just builds up to the similar work I was mentioning earlier. So, how can we say that the thoughts match what it outputs, right? So, if we can measure this, we can get something we can start estimating how good how faithful a model is or how unfaithful it is, okay? So but the fact that its faithfulness was at the high the faithfulness violation, sorry, the violations of the faithfulness were at 80% accuracy, over 80% actually. It means that it wasn't really trying to be clever, like hiding the mismatch, between what it says and does. Like it's just showing me that the information is there, right? Organized, as if label, and it even organized it and they even label it, but it doesn't even try to hide it. So what we fascinated and what we had assumed earlier is that this model will try to hide it, right? But it will just be hidden. It will hide everything very, very well, and we wouldn't find it. Have some complex linear pattern, then we do another experiment, but it did. it's just wide open there, like the information is just open there. So that was so interesting. So it means like for one, we can breathe a fresh air, we can have a breath of fresh air that at least we don't have them bad yet. But it also just raises question like, what if they get more sophisticated, right? How will they hide those patterns, or will they remain the same? But yeah, that was this most surprising thing about the faithfulness of these current systems. But
Right.
it's ongoing workforce things. Yeah,
Okay. All right. Okay, so Victor, we talked about the issues, we talked about the models, neural networks, right? So I think now it's the
yeah.
time to conclude the overall discussion in terms of neural network. So from your expertise, where does AI safety research currently stand? Like, are we ahead of the risk, behind them, or we are just barely keeping the pace? So overall, how you look at this overall AI safety research currently stand there?
Awesome. This is a great question. Yeah, I know my friends are very interested to see the points I'm sharing, but yeah, anyway, I'll be very honest.
Okay.
We are sort of behind. We are scaling the models way faster than what the safetists, we call
Yes.
each other safetists. Yeah. Anyway, what the safetists we need to do, right? But hopefully not for long. Okay. So the capability research is making the models more faster, more capable, still massively
Okay.
outpaces the safety and understanding, right? So the safety is still lagging because we are still trying to find new roles. We're still trying to understand the safety, still to understand like the nitty-gritty of each neural network and packing them, right? I mean, there is also promising work of compacting, but understanding it broadly, but we are still there. If you compare to how fast, GPT-5 is, or how Claude 4.6 is, right? Like, look at how smart it is. Like, it can write code, it can do Excel sheets, it can output a PDF, all
Correct.
things that GPT-2, 3 struggled, and it's like a gap of 2 years, right? But our understanding is still somewhat behind, right? So, but the
Correct.
field has grown enormously in the last 2 years. That's also another great point. The work that was done over the 2023, 2022, and the work done now, it's a bit different. The work done over there, even if you just look the work, it was way smaller. It's very, very small. It was just like understanding like sparsity, weight, just like it was so basic, right?
Mm.
So it went from mechanistic, like mechanistic interpretability. It went from a niche interest to like a real research program now. Now it has departments. Now this is the good thing. Now this is the growth we've seen. Like it has teams at Anthropic, DeepMind, and even OpenAI, even some small labs. There's a small lab called Redwood Research. It's in
Correct.
California. But like, yeah, so I think there's been programs that have been here and there that are growing to help people learn, that are all over the place, that are working, like the programs that like Maths and Blue Dot, right? So it makes this safety work more available. But another issue is that we are not so many on this side. Everyone is just excited to scale. Yeah. Back to question. I think that was question two. Everyone wants the more travel. Everyone wants to scale them. Yeah, I
Mm.
get the fascination with that. Yeah, but again, I'm happy that it's growing. So the growth has been so immense, and I'm hoping it grows even further than that, right? In 2026 alone, right? There's so much promise this year alone. If we get more people to do work around this, more people to if we can poach people from capabilities teams, that will be good for us. Yeah. So that we are not just we are not just people who want to push the limits alone. We just also want to understand, right? We need to have that thrill to make people come to our side. But yeah, that's currently it's behind, but the trajectory is encouraging. I will say that is really, really encouraging. There's a lot of promise, essentially. But yeah, that's where we stand right now.
Okay, so we can say that growth is not wrong at all. Like it should grow rapidly, but at the same time, we should focus on the security part as well because that is also a great concern. Safety is a concern. So growth is
Yes,
not
yes,
wrong,
yes.
but safety should be there. Okay.
yeah, essentially like they should match, we shouldn't have one lag behind the other.
Correct, correct, correct.
Yeah.
Okay. All right. So, yeah, Victor, we talked about so many technical things. It's now time to know a bit more about you, your journey, your support network, and the place you belong from. So, firstly, I just wanted to know, like, looking back on your own career, who are the key people who had a defining impact on your journey so far?
Whoosh. Yeah, let me start somewhere. My parents. Yeah, of course. My parents have been like the first support. When I was like 19, 18, and I used to like push them. There is a new speaker in town. There is this boot camp in town. I want to attend. Please, please, please. Yeah, I used to push them there. It was so crazy. I even didn't want other universities because I wanted this Kabarak is more tech oriented. I even pushed them. I changed, oh, dad, mom, please help me go to this university. I won't even stay in this house. Of course, like, what they do, I was doing empty threats. But yeah, anyway, that's a story for another day. So my parents have been like,
Yeah.
have been really a growth push for me. They're pretty much non-technical, but every time I just tell them these things, they get fascinated. It's just they get fascinated, but they're like, we don't know this AI, Victor, what do you want this AI? So when they call me, when they have like opinions on everything, it's so interesting on that front, because they're the ones who even push me. Looking back, like tech general, I think now going into like things around like community. I will say like my leader, the current lead at GDG Pwani has been a very amazing guy. His name is Wenga Ko, very great guy. He's also a GD in Angular. We met casually at a conference, at a Google Developers Conference a while back, and then we just sort of hit it off. And then he was like, no, Victor, oh no, you need to come to GDG Pwani, lead my part. No, he actually just invited me to come help me run things. And then he found I'm just good at talking to people about partnerships and forming new partnerships with the community. And then he's like, you take over the partnerships. Now it's yours. And then that's eventually, he's a very great guy. Also, he's the one who recommended me to the GDE program. I wasn't even
Okay.
aware. He just recommended to the local ecosystem manager of Sub-Saharan Africa. Then I found an email. I'm like, wait, I didn't even apply to this. Where is this email? Then he just calls me and says, no. I talked to him, sorry. And he said, like, yeah, I did that. That was me. Yeah.
Okay.
And then, like in the industry general, there is like people like Neil Landa. He's one of the best AI safety researchers around. He's been a very great work. Professor Mark Stegmark, that is also great work. Greenblatt at a small lab there. It's called Redwood. Yeah, those have been very great. These are people who have just like, you push questions, you share ideas, they push it. The team at Blue Door, there is Aya, uh, there's Kara, these great people who have also we've shared ideas, like people who are pushing me like, Vicky, you can do this, please, please, please. Come." When you're sort of trying to lag behind, but then you remember there are people who are like, okay, Victor, you can actually do this. You need to push it further. So I would like to also thank them. Like these ones are specifically for their safety. They really helped me even grow even further. I'm still thinking I'm just in the field right now, but I'm also growing. So it's very interesting that I've had people who also like to hold hands, share ideas, listen to their talks, be close to them, ask questions, etc. Yeah, that's pretty much it in the journey so far. But I'll probably have a longer list. I'll probably mention like the extended family. A lot of friends. Those who just shared random ideas, of course. But like I'm looking at the highlights, and these are people who will definitely come up on my mind anytime.
Yeah. Okay, Victor. So, Victor, although like there are so many things that we can discuss on AI and your contribution to the IT, but we have limited time, so I just want to take one last question. And this question is related to the place you belong from, Kenya. So, as a proud citizen of Kenya, like what is one thing about Kenya that you would like to share with the rest of the world?
Yeah. Oh, Kenya. Kenya is so resourceful. I'm not even being biased and everything. Kenya is like a growing we call it a silicon savannah, by the way. It's a legal name that has grown because of the ecosystem. That's like looking at tech alone. Like mobile money we had mobile money as early as 2007, right? And then it just happens that at the same time, backing infrastructure, the fintech started growing at the same time. And it grew from there. Now we have civic infrastructure, we just have agricultural startups, agri-tech startups that are building in Kenya because of just the environment of Kenya itself. So Kenya is just a very booming tech ecosystem. Don't get started on the communities. I think we have like five GDGs in Kenya in total, right? And it's really amazing. They're all huge. They can all do events and they can just bring a whole number of people. So if you need a community, just interact with people. Kenya will just be one good for you. And then look at like, generally the people. We are so hospitable. That's one thing we are known for, right? So hospitable, right? Come to Kenya right now, get lost, and then it's not like someone will just take advantage of you, leave you there. Someone will probably take you to their home, right? Because of just hospitality, right? And then we have so many places to visit. I can't even start where to bring, but just, if you come to Kenya, then we have the sandy beaches in Mombasa. We have the northern Kenya, known for its the desert conditions, but just general calm. And then we have the central Kenya because of the highlands. If you're a mountaineering guy, you have Mount Kenya, we have Mount Longonot. It's just the list is so endless, right? We call it magical Kenya, and also it's the cradle of mankind. There's a place called Turkana. Historians say there is a bunch of geology, historical sites there that prove the cradle of mankind started here in Kenya,
Okay.
in the north. So it's another fascinating bit about Kenya. Like general, we just have general peace, right? Like relative peace. We don't have any growing things like constant civil wars, like chaos of post elections. So we are so glad for that. We thank God for that because we just experience any time of the year. So it really doesn't matter. So you can just come here for the tech, come here for the tourism, hospitality industry. Actually, the hospitality industry is booming. Yeah, that's for one.
Yes.
You won't miss anywhere to stay or sleep. You can just come here just to studies. Actually, we have the education tourism. It's a thing now. We have people from all over the world come here just to learn languages, Swahili, or just do general education. So I don't know if we were to start about Kenya, but just one word, magical Kenya. Right. Also, the movie, by the way, that Disney movie, what's the name? The one about Lion King was
Okay.
filmed here in it's a place called Masai Mara. Yeah, so there's just a lot about Kenya, but it's just general cool country. I love this place. When sometimes I travel, just the feeling of getting back here, it's like, whoosh, oh, I'm back home. I'm back home. It's really great. Kenya's a real chill country, right? Like you can just live here your entire life. And just enjoy it. Like you could call it a retirement home. It's just the vibe about Kenya. It's that chill retirement country home. But yeah. So this is the thing about Kenya. Just say magical Kenya
Magical.
for the people watching. Yes.
Yeah, so it's quite interesting to know about some of the places that Kenya had, and also you just shared about the Lion King movie that it is also shot there in the Kenya itself. So
Yes.
I'm sure those who love that movie they know how precious the place is, especially the Kenya.
Yes.
So they should keep the magical Kenya, I would say, in the bucket list
Yeah.
to visit and travel next in their plan, so that they will find more interesting things there.
Yeah. Put it in your plans.
Okay. All right. So, yep. Thank you so much, Victor, for joining us today in this episode and for sharing so much information about the AI, your contribution, neural network also. It was really very fascinating, all journey the which you have traversed so far and the kind of way you are contributing to IT industry. So it was pleasure talking to you. So thank you once again for being a part of the show.
Yeah, thank you, Shamit. I'm so honored for the invite. By the way, it's a great platform. It's very great to connect for one, another global GD, another tech enthusiast, and just someone who's really interested in tech. I can see from the way you assemble the questions, it's you're fascinated about the tech contributions. Honestly, I love this podcast, and I'm looking forward now because I didn't know it before, but now I'll be keep an eye on it, watching the next interviews, and yeah, really hope people like it. And yeah, see you next time. So thank you so much.
Thanks.